Okay, good afternoon. Let us today study some more important things on this chapter. Chapter so called ray optics and optical instruments. Correct? Okay. What do you mean by thin prism? Let's start with the thin prism. Today's class, let us start with thin prism. Okay. What do you mean by thin prism? A thin prism is one whose angle, if angle of prism is less than 10 degree, then the prism is said to be thin prism. Let me repeat. If angle of prism is less than 10 degree, then prism is said to be thin prism. Thin prism. Very thin in nature. What is important here is deviation produced by what we have to study? We have to study deviation from here I can write deviation produced by a thin prism. We have very small derivation, okay, which we often use in solving problems. When solving problems, we are supposed to use this relation. Relation is called deviation produced by a thin prism. Now, question is, what do you mean by thin prism? As we discussed earlier, a thin prism is one whose angle of prism is less than 10 degree. A thin prism. See, we know refractive index of prism is given by N2 is equal to sin A plus dm divided by 2 angle of deviation divided by sin A by 2. Say equation 1, correct? We know this. Actually, we derived this equation in last class, correct? Okay. For thin prism, this is sin A plus dm by 2 is almost equal to, you can neglect sign. We can neglect sign. So I can write it as A plus dm by 2. This is only for thin prism. I can what? Drop this sign. For small angles. Small angles. Okay. Also, sin A by 2 is almost equal to what then? Is almost equal to A by 2 only. Correct? Hope you understand. Correct? Sin A plus dm by 2 is almost equal to, neglecting the sign, what we get? A plus dm by 2. Here, sin A by 2 we have, neglecting the same sign, what we have? A by 2. If I write this in equation 1, what I get? N2 1 is equal to, instead of sign, I have written what? Divide by 2, divide by A by 2. Correct? C. Correct? Next. N2 1 is equal to A plus delta n divided by 2 into 2 divided by 3. I can take reciprocal of this denominator. This A by 2, I will write it as 2 by 8. This is A by 2, I will write it as 2 by 8. So, you can cancel this. And this cross multiply this A. What we get? A into N2 1 is equal to A plus delta M. This is the equation we get. Correct? This equation we get. Fine. What next? See, I will write that equation as E refractive index of medium 2 with respect to medium 1 minus A. Let me transfer this A to this side. So what I get? Then A 10 to 1 minus A is equal to eta M and dm, or A, I will write this dm first. Dm is equal to A into bracket refractive index second medium with respect to the first medium minus 1. This is the expression. This is the expression for what? Deviation produced by increasing. This gives you what? Deviation. This is dm is deviation. Deviation produced by increasing. dm is equal to A into bracket n to 1 minus 1. Simply you can write n here. No problem. This equation is helpful while solving problems. While solving problems. Okay. Let's continue. Our concept is dispersion. Today's actual concept is dispersion. Okay. Let me write dispersion. What do you mean by dispersion? Dispersion ಅಂದ್ರೆ ಏನು? ಬೆಳಕಿನ ವರ್ಣ ವಿಭಜನೆ dispersion probably no? I'm not sure, but it is a term. ಬೆಳಕಿನ ವರ್ಣ ವಿಭಜನೆ dispersion. Like, what do you mean by dispersion? We know, as we know earlier, your white light from sun is called composite light. ಸೂರ್ಯನಿಂದ ಬರುವ ಬೆಳಕಿಗೆ ನಾವು ಬಿಳಿಯ ಬೆಳಕು ಅಥವಾ ಸಂಯುಕ್ತ ಬೆಳಕು ಅಂತ ಇಟ್ಸ್ ಕಾಂಪೋಸಿಟ್ ಲೈಟ್. ಇಟ್ ಕನ್ಸಿಸ್ಟ್ ಆಫ್ 7 ಕಲರ್ಸ್. ಅದರಲ್ಲಿ ಎಷ್ಟು ಕಲರ್ಸ್ ಇದ್ದಾವೆ? 7 ಕಲರ್ ಇದ್ದಾವೆ. ನ್ಯೂಟನ್ ಫಸ್ಟ್ ಟೈಮ್ ಡಿಡ್ ದಿಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ where we know all these things by our primary and high school things. The constituent colors of composite light are V, I, V, G, Y, O, R. 1, 2, 3, 4, 5, 6, 7. Where V stands for violet, I indigo, V blue, G green, Y yellow, O orange, and R red. Vibgyor is what we call it as Vibgyor. Or you can write ROYGVIV, whatever it is. Vibgyor. This phenomenon, when a beam of course, narrow beam of, please underline, a narrow beam of composite light is made to pass through a prism, then light will split into its constituent colors. What? Your light will split into constituent colors. This phenomenon is called dispersion. What do you mean by dispersion? Very simple. Dispersion is a phenomenon in which a composite light, after passing through prism, will split into its constituent colors. You know this from your high school or primary school. I will draw a prism, a ray, composite ray, of course, a ray, composite ray, X, Y, Z in the prism that is in base. We know what? The number of colors produced. Okay? 1, 2, yellow, yes. 3, almost green, okay? Not exactly green. Green. Okay. I have done here blue, indigo. I don't have indigo. Okay. Indigo and violet. Sure. No problem. All the colors again. This is somewhat easy. See, V, I, right here, V, I, V, G, Y, O, R. Or V, I, V, G, Y, O, R. In this direction. Usually we write in this direction, remember? But actually, your violet color deviates most. Which color deviated most? So violet deviates most, whereas red deviates less. By the discussion, we observe some interesting things. What? First thing is, see, this is actual path traced by the light, actual path traced by the light in the absence of dispersion. Due to presence of dispersion, we get this fascinating colors, with colors called vidya. Here, what we observe, bending of our violet is more, and red has least bending. All the colors will lie between violet and. What's the reason behind that? Why this discussion occurs actually? Remember, refractive index of medium. I am telling about and I am talking about refractive index. Refractive index of medium for different colors or different wavelengths. I am using one more term, wavelength. Different colors or different wavelength is different. Say, refractive index of your red light is around 1.51. Roughly, it has some values 1.5 and something. Your refractive index of your violet is 1.53. It's better. Hope you understand. Refractive index of the medium for different color is different. This color, concept of color, is associated with the wavelength of light. See, this red has longer wavelength. Red has longer wavelength. Wavelength of red is almost equal to 700 nanometer. 700 nanometer. And wavelength of your violet is almost nearly equal to, okay, wrong term I used, almost equal to, nearly equal to 400 nanometer. Our whole visible region lies between this 700 nanometer to 400 nanometer. These are rough values anyway. Okay, remember. Let's remember these values only, 700 nanometer to 400 nanometer. This red has higher wavelength, longer wavelength, whereas violet has what? Shorter wavelength. This violet, indigo, blue, green are called lights, colors of shorter wavelength. Colors of shorter wavelength. This red, orange, yellow, purple colors of longer wavelength. And what about the speed? Your red has maximum speed. Your red has higher speed compared to your violet. Red has more speed. It moves faster. Its wavelength is more. It moves faster, but it bends less. Bending of red light is less. Whereas, as compared to violet wavelength is less. Its speed is also less, but its deviation is more. We can connect all the things now. We can define refractive index and connect. And one more assignment, let me give you. Why we use red lights on the tower of, usually on the tower of a mobile towers? We can see in the night a red light blinking when aeroplane is moving about. Okay, or most of the star signals contain red symbol, and when you break your what scooter, bike, or car, the red light for stop, correct? There is some symbolic. Okay. Then we have some indicator, right? Indicator is orange in color, correct? Probably they have what higher wavelength. Wavelength value is higher. That's why they are using. Just I am thinking, may not be true also. Whatever. Okay, this is what dispersion. What we have discussed in dispersion, we have discussed. Okay, red color bends least, whereas violet bend more. Wavelength of red color is more. Wavelength of violet is less. Okay, next. Refractive index of the red color is 1.51. Roughly, refractive index of the violet is 1.5. This is enough, I think. Okay, that's where dispersion is concerned. What is important is where you observe this dispersion in nature. Where you observe this dispersion in nature. Okay. Most of us have seen what rainbow. Rainbow is due to dispersion of light in nature. By what? By water droplets, raindrops at certain height. Rainbow is one of the most beautiful thing we observe in nature, correct? Most beautiful thing we observe in nature. When we observe rainbow, remember, rainbow is observed when your sun is shining at one end of the sky, and it's raining opposite end. When your back is toward the sun, ನೀವು ಸೂರ್ಯನಿಗೆ ಬೆನ್ನು ಮಾಡಿ ಇಟ್ಕೊಂಡಾಗ ನಿಮಗೆ ಆಚೆ ಕಾಣ್ತಾ ಇದೆ ರೈನ್ಬೋ ಕಾಣ್ತಾ ಇದೆ. ಏನು ಕಾಣ್ತಾ ಇದೆ? ರೈನ್ಬೋ ಕಾಣ್ತಾ ಇದೆ. Rainbow is due to sunlight falling on water molecule in the water droplets. rainwater, I mean to say water droplets, and dispersion occurs in the water droplet. Remember, strictly speaking, your rainbow is due to combined effect of. Let me repeat the thing. Your rainbow is strictly due to combined effect of dispersion, refraction, and total internal reflection. Let me repeat. It is due to combined effect of dispersion, total internal reflection, and refraction. Okay. There are two types of rainbow we observe. Probably you observe that. Rarely we observe this. One rainbow is very strong in nature. I mean to say very dark, and above that rainbow we observe one more rainbow which is very faint. ಎರಡು ತರ rainbow ನೋಡ್ತೇವೆ. ಒಂದು ಸ್ವಲ್ಪ ನೋಡುವಾಗ ಡಾರ್ಕ್ ಆಗಿ ಕಾಣ್ತದೆ, ಕರೆಕ್ಟ್ ಆಗಿ ವಿಸಿಬಲ್ ನೀಟಾಗಿ ಕಾಣ್ತದೆ. ಮತ್ತೊಂದು ಸ್ವಲ್ಪ ಫೇಂಟ್ ಆಗಿ, ಅಂದ್ರೆ ಅಷ್ಟು ಸ್ಪಷ್ಟವಾಗಿ ಕಾಣೋದಿಲ್ಲ. The first one, which is very much neatly visible, is called primary rainbow. ಅಂತ ಹೇಳ್ತಾರೆ primary rainbow. The second rainbow, which is fainter as compared to first one, the second rainbow, which is fainter as compared to first one, is called secondary rainbow. Okay. Example, ಈ ತರ ಕಾನ್ಸೆಪ್ಟ್ ನಮಗೆ ಕೇಳಿಲ್ಲ, but being a science student, let's understand this substance. Okay, this is the intention. Okay, how actually rainbow possible with what water drop, water droplet? Okay, let this be water drop or water droplet. A sunlight when enter this water droplet, dispersion of light takes place. Say this is red, this is violet. Why? Red is bent diagonal, violet is deviated to opposite. Then what? See? Okay, no problem. Here we have red. I will draw somewhere here. Here we have violet. Then violet will bend like this, violet and red. With respect to incident wave, the angle made by violet is around 40 degree. With respect to incident wave, the angle made by violet ray is 40 degree, and angle made by red light is around 42 degree. In this condition, we observe what? We observe rainbow. See, here we observe three phenomena simultaneously. What? One, diffraction. Second, internal reflection. Third, diffraction. Of course, this dispersion is there. See, this is due to refraction, reflection, and diffraction. This is the first diffraction, second reflection, total reflection, third once again reflection. Okay, this is how. Okay, one more thing I forgot to mention. What? Yes. To show primary rainbow, we have to consider two water molecules. Okay? See, one droplet, first droplet, water vapor. Okay? Area of light from sun ray, beam of sunlight, refraction, total reflection, and we observe what here violet, most deviated, and red. This is due to first droplet. Let us consider one more drop somewhere here. Correct? This is violet, this is red. Now I will take actual colors. This is violet, this is red. With respect to normal, red bends least, violet bends most. Once again, if you consider one more ray, okay, parallel to this, refraction, reflection, once again refraction. Okay. Here, once again, refraction, reflection, refraction. Once again, same phenomenon. What? Here goes violet, most deviated, and we have red. Please deviate it with respect to normal. Okay. See, this is a cause for your primary rainbow. Primary rainbow. In primary rainbow, see, I have red, here violet, here red. Okay, some colors are just mixed randomly here. V I D G somewhere here. Okay. In this portion, see, only in this portion. mm, Okay, let's stop. Now, okay, no problem. Deconnected, okay. See, I am telling in primary rainbow, you observe red at the top. What you observe? You observe red at the top. ಪ್ರೈಮರಿ ರೇನ್ಬೋದಲ್ಲಿ ಮೊದಲನೇ ಕಲರ್ ರೆಡ್ ಆಗಿರುತ್ತದೆ. ಪ್ರೈಮರಿ ರೇನ್ಬೋದಲ್ಲಿ ಫಸ್ಟ್ ಕಲರ್ ಏನಾಗಿರುತ್ತದೆ? ರೆಡ್ ಆಗಿರುತ್ತದೆ. ಕೊನೆಯ ಕಲರ್ ಏನಾಗಿರುತ್ತದೆ? ವೈಲೆಟ್ ಆಗಿರುತ್ತದೆ. ಕೊನೆಯ ಕಲರ್ ಏನಾಗಿರುತ್ತದೆ? ವೈಲೆಟ್. ಮತ್ತೊಂದ್ಸಲ ಹೇಳ, ಇದು ಪ್ರೈಮರಿ ರೇನ್ಬೋದಲ್ಲಿ ಫಸ್ಟ್ ಕಲರ್ ರೆಡ್ ಆಗಿರುತ್ತದೆ, ಕೊನೆಯ ಕಲರ್ ಏನಾಗಿರುತ್ತದೆ? ವೈಲೆಟ್ ಆಗಿರುತ್ತದೆ. ಮತ್ತೆ ಸ್ವಲ್ಪ ಅದು ನೋಡುವಾಗ ಸ್ಟ್ರಾಂಗ್ ಆಗಿರುತ್ತದೆ, ಅಂದ್ರೆ ವಿಸಿಬಲ್, ನೀಟ್ಲಿ ವಿಸಿಬಲ್, ಕ್ಲಿಯರ್ಲಿ ವಿಸಿಬಲ್. In primary rainbow, the top color is red, whereas bottom color is violet. And this violet color from first droplet, this violet color from first droplet, and this red color from second droplet. This violet color from first droplet, this red color from second droplet are scattered away. They are taken away. As an observer on the surface of the earth, I am not able to see these two colors. What two colors? Violet color from first droplet, red color from second droplet are scattered away from a person, observer, who is standing on surface and observing the rainbow. The only reason we can see is red from first droplet, violet from second droplet. So total color will be seen on the top of the rainbow. You see red color. At the bottom you see what? Violet color. This is called primary rainbow. Primary rainbow is due to three-step process. Primary rainbow is three-step process where we observe refraction, reflection, and refraction. Refraction, reflection, and refraction. Please see. This is point A. This is point B. This is point C. A, refraction and dispersion mode of. B, total internal reflection. C, one more refraction. Okay, first thing. Primary rainbow is due to a three-step process where refraction, reflection, and refraction. Second, it is clearly visible as compared to secondary rainbow. Point number 3. The top color, the top portion is red and bottom portion is violet in case of primary rainbow. Hope you understood. Okay. Now, let's move to secondary rainbow. Let us consider a rainbow. The light A sunlight when enters this droplet will get reflected first. This is point A, reflected, which is a point B. When sunlight enters the raindrop, in case of secondary droplet, first at point A, diffraction takes place. Hence, there is a division of colors. At point B, it undergoes total internal reflection. What? Total internal reflection. At point C, once again it undergoes total internal reflection. Total internal reflection. Then, if you draw a model, we observe red light here, violet here. This is red light, this is violet. Now you observe red light is on the top, violet is at the bottom of this drop. Your secondary droplet is four-step process. Your secondary, what we call rainbow is four-step process. Your secondary rainbow is four-step process. Refraction at A, reflection at B, total internal reflection, reflection at C, and refraction at D. Okay? Due to two internal reflections, the intensity of light decreases. Due to two internal reflection inside the water molecule, intensity of light decreases. Hence, it is fainter, not clear as primary rainbow. Hope you understand. In secondary rainbow, due to multiple two times reflection inside the water drop, what happened? The intensity of light decreases. Due to this intensity of light, decrease in intensity of light, your secondary rainbow is fainter. Okay, let me consider one more droplet. Okay, same process. Array, refraction at A, reflection at B, refraction at C, and reflection at C at D. Once again, this is red. Okay, sorry, I will draw red like this. This is red. This is violet. Similarly, okay, here too, observer on ground cannot see red color from first droplet and violet color from second droplet. The only area visible to observer on ground is violet to red. The only area visible to observer on surface of earth is violet to red. Here, colors reversed. Color in reversed. In case of primary droplet, primary rainbow, we observe at the top red color, whereas here we observe at the top violet color. Well, violet color is at the top and red is at the bottom. It's a reverse. You may ask to write any three differences between primary rainbow and secondary rainbow. You may. Okay, ಅವಾಗ ಏನು ಬರೀತೀರಾ ಫಸ್ಟ್ ಏನು ಹೇಳಿ ಫಸ್ಟ್ ಪ್ರೈಮರಿ ರೇನ್ಬೋ ಬಂದು ಡಿಜಿಟಲ್ ಪ್ರೊಸೆಸ್ ರಿಫ್ರಾಕ್ಷನ್ ರಿಫ್ಲೆಕ್ಷನ್ ಸೆಕೆಂಡ್ ರೇನ್ಬೋ ಪೋಸ್ಟ್ ಪ್ರೊಸೆಸ್ ರಿಫ್ರಾಕ್ಷನ್ ರಿಫ್ಲೆಕ್ಷನ್ ರಿಫ್ರಾಕ್ಷನ್ ಪ್ರೈಮರಿ ರೇನ್ಬೋದಲ್ಲಿ ಮೇಲಿನ ಕಲರ್ ರೆಡ್ ಕೆಳಗಿನ ಕಲರ್ ವೈಲೆಟ್ whereas in secondary rainbow upper color is first color is violet and last color is red. This one intensity of primary rainbow is greater very much, whereas intensity of secondary rainbow is less. It is fainter than primary rainbow. These are three major differences between rainbow, what primary and secondary. Hope you understand. Okay. Let me continue. I'm not wasting time. Okay. This time is precious, you know. Okay. Next concept is scattering of light. One more important concept on this chapter. Anyway, these concepts carry only 1 or 2 marks. Okay, not more than 1 or 2. Okay, scattering of light. ಬೆಳಕಿನ ಚದುರುವಿಕೆ. Scattering means ಚದುರುವಿಕೆ. ಒಡೆಯುವುದರ ಚದುರುವಿಕೆ. ಬೆಳಕಿನ ಚದುರುವಿಕೆ. Scattering of light. When sunlight enters the Earth's atmosphere, it what collide with the atmospheric particles like molecules present in the air, dust particles, okay, any bigger kind of molecules. When it scatters, when it collides with the particle of the medium, atmosphere is a medium, light is deviated from its original path. Light is deviated from its original path. This phenomenon is called scattering of light. This phenomenon is called scattering of light. One second, let me explain. Okay. How to define scattering then? Scattering, very important. Scattering is an optical phenomenon. Scattering is an optical phenomenon in which particles of the medium deviate direction of the light while passing through it. Let me repeat. One second. Okay. Right. Scattering is optical phenomenon. Scattering is an optical phenomenon in which particles of the medium deviate the direction of light while traveling through the medium. While light traveling through the medium. ಯಾವ ಮಾಧ್ಯಮದ ಕಣಗಳು ಬೆಳಕಿನ ಕಿರಣವನ್ನು ಡಿವಿಯೇಷನ್ ಆಗುವ ಹಾಗೆ ಮಾಡ್ತಾರೆ. ಆ ಪ್ರೊಸೆಸಿಂಗ್ ಆ ಫಿನಾಮಿನಾ ಕರೀತೇವೆ ನಾವು ಸ್ಕ್ಯಾಟರಿಂಗ್ ಅಂತ. ಸ್ಕ್ಯಾಟರಿಂಗ್ ಎಲ್ಲ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೇವೆ. ಸನ್ಲೈಟ್ while coming from the distance, when it enters the Earth's atmosphere, it deviated due to particles present in the atmosphere. What is the effect of this scattering? There are 2 consequences of this scattering, natural consequences of this scattering we have listed. First one is blue color of what? Blue color of sky. Have you ever wondered why sky is blue? ಆಕಾಶ ನೀಲಿ ಏಕೆ ಇದೆ? ಯಾವತ್ತ ವಿಚಾರ ಮಾಡಿದ್ದೀರಾ? This blue color of sky is due to scattering of light. There is one more phenomenon, one more natural thing we observe in our daily life is, this is first one. Second one, red color. During sunrise and sunset. ಸೂರ್ಯ ಉದಯಿಸುವಾಗ ಮತ್ತೆ ಸೂರ್ಯ ಮುಳುಗುವಾಗ ನಮಗೆ ಆಕಾಶ ರೆಡಿಶ್ ಕೆಂಪಾಗಿ ಕಾಣುತ್ತದೆ. ಯಾಕೆ? ಕೆಲವೊಂದು ಟೈಮ್ ವಿ ಸಿ ವೈಟ್ ಕ್ಲೌಡ್ಸ್, ಬಿಳಿಯ ಮೋಡಗಳನ್ನು ನೋಡ್ತೇವೆ, ಬೆಳ್ಳಿ ಮೋಡಗಳನ್ನು ನೋಡ್ತೇವೆ. ವೈ? We can explain all these natural phenomena using the concept of scattering. By help of scattering, by using what concept of scattering, we can explain why sky is blue, why we observe red color during sunrise and sunset, and even white clouds also. Okay, let's study one by one. Okay, to understand this phenomenon, we have to study one law. I will write important. Somewhere here I will write important. That law is called Raleigh's law. What? Raleigh. Name of the scientist. Raleigh. Raleigh's law. Raleigh's law. Okay? Raleigh's law. According to this law, the intensity, we are talking about intensity, I. The intensity of scattered light, the intensity of scattered light is inversely proportional to fourth power of wavelength of light. Is inversely proportional to fourth power of wavelength of incident light. Better. Fourth power of wavelength of light. This is lambda, okay? Well, this. Okay, I will explain this. This is I, stands for intensity, inversely proportional to, this is lambda, wavelength, fourth power of wavelength. Let me repeat Raleigh's law. According to Raleigh's law, the intensity, I, intensity you know, intensity of scattered light is inversely proportional to 4 power of inversely proportional to 4 power of wavelength of light, wavelength of incident light. If you know this law, we can explain blue color of sky. Okay? See. Okay? These are lights of longer wavelengths. Okay? I will just longer wavelengths or longer lambda. These are lights of shorter lambda. Okay? Your violet, indigo, blue, or colors with a shorter wavelength. Let me repeat. Your indigo, violet, blue, or colors with shorter wavelength. Whereas your red, orange, yellow, or colors with a longer wavelength. Correct? Now, see here. This lambda is in denominator. This lambda is in denominator. Now, if lambda value is less, intensity will be more. Yeah, it must be correct. If lambda value is less, intensity is more. These are shorter wavelengths, lambda value is less, their intensity is more. Okay, what actually happens? When sunlight enters the Earth's atmosphere, it will get scattered by molecules present in the air, atmospheric molecules. Due to Raleigh's scattering, due to this equation, Raleigh's scattering, lights with light with shorter wavelengths are scattered more. Light with a shorter wavelength will scatter more. Even scattering depends on size of the particle. We will discuss it later. There is one more parameter. Size of the object is also, particle is also important. Matters. Whatever it may be. For time being, see, light of shorter wavelength scatter more. And these light reach the person, observer on the earth. If I am observer observing the sky, then sky may appear me as a violet, indigo or blue. But still we observe sky in blue color only. Why? The reason is human eye is more sensitive to blue color than indigo and white. Or human eye is more sensitive to blue color. And we see sky as a blue. Let me repeat the process. See, when sunlight enters the Earth's atmosphere, it gets scattered. The scattering is what? More for colors with lower wavelength or shorter wavelength. In shorter wavelength, these violet, indigo, blue are scattered more and they reach observer. But for a man, human, for man, your blue color is more what? We are more sensitive to blue. Observer is more sensitive to blue. So we feel color of the sky as blue. Okay. What is the reason for red color during sunset and sunshine? Sunset and sunrise. Same reason. Once again, Rayleigh's equation. During sunrise and sunset, light has to travel longer distance in environment, in atmosphere. Light has to travel longer distance in atmosphere. While traveling longer distance, these lights or colors of shorter wavelength scattered away. They get scattered away from the observer. Only those light with longer wavelength reach the observer. In longer wavelength side we have yellow, orange and red. So we feel reddish during the sunset and the sunrise. During sunrise and sunset, sunlight has to travel longer distance in atmosphere. During this traveling, most of the shorter wavelengths are get scattered away from the observer. Observer cannot see those colors. Only colors with the longer wavelength reach the observer. And we feel the color of sky is reddish. Then we can also explain this one, white color. If size of the particle is quite bigger, particle means scatterer which scatters the light, is scatterer, okay, quite big. All colors are what scattered equally without difference. Hence, we observe what there are some white clouds also. This white clouds is due to scattering of all colors with the equal thing. Okay, hope you understand. This is all about scattering. Okay. Probably this is my 12th class as far as this chapter is concerned. I am supposed to finish it within 10 working hours, 10 periods. But we have taken 2 more extra periods, correct? Now I will try to complete within 1 more period. Probably tomorrow I will finish the chapter. Okay. Last another 5 minutes I will stop the things. Now it is time to study optical instruments, last part of the chapter. Optical instruments. The name of the chapter is ray optics and optical instruments. Now we are at the stage where we are supposed to study optical instruments. In optical instrument, the first optical instrument we are supposed to study is simple microscope. You know simple microscope. These microscopes are used in biology lab, correct? Yeah, okay. Or you may use it as a reading lens also. Reading lens also, no problem with it. Simple microscope. Actually, before last year, we have to study in this chapter human eye and some of the shortcomings of eye, some of the not disease actually, they are not disease. What we call problems related to eye, like hemophilia. I mean, so this one hypermetropia, presbyopia, presbyopia, right? Hypermetropia, all those things related to eye. Actually, that concept was taken away from the chapter. We are not supposed to what now teach you those portions. Okay, so we'll just leave that concept and let's move on to this chapter. Simple microscope. Here we have to draw a ray diagram for distance of distinct vision, or it is called near point. It is called near point. How microscope we can use? We will have to draw image formation at near point. Let's draw one by one. Okay. First point. Image formation at near point in case of simple microscope. Okay, this near point is also called least distance of distinct vision. Let me write here only. Least distance of distinct vision. What is near point? As I told earlier, we are not supposed to study human eye now. This year. Okay? I hope. We are not supposed to study. Now it's very difficult concept if you are not studying this one. What human eye? Let me explain. Okay? What is near point or least distance of distinct vision? The shortest distance is near point, or least distance of distinct vision. The shortest distance for which our eye lens can focus light on your retina. No number of questions in your mind, right? What is eye lens? What is retina? Okay, I will tell you. We can read, we can see things at certain distance. If it is beyond a certain distance, things will be blurred. In your eye, you have one eye lens. The primary function of this eye lens is to focus light from distant object. There is certain limitation. For a very normal man with a healthy personality, all those things, this normal vision is around 25 centimeter. It's around 25 centimeter. If it is more than, if it is less than 25 centimeter, the image formed on retina is a part of eye where image is formed. I will not go into detail, definitely in detail. Okay? Okay. Let me tell you. It is the shortest distance at which your retina can focus, your eye lens can focus ray of light on retina. Is called near point. Okay? When object is placed in front of convex lens, please listen carefully. When object is placed in front of convex lens between focus and optical center, the image is formed in the same side. If you are very much what particular, or if you know clearly image formation in case of lens for different positions, then it's very easy to understand this concept. Let me repeat. If you understand, if you know formation of image in case of convex lens for different positions, then it will be very easier to understand this concept. Imagine an object is placed in between focus and optical center. Then where actually image is formed? What is the nature of image? If you remember, image is formed to the side of the object. It is virtual, erect. This position of simple microscope is called what? Near point. Near point or least distance of distribution. If you place second, there is second part also. You have to draw that also. If you place your object exactly at F, principal focus, then your image will be formed at infinity. That part is called when image is placed at infinity. When image is placed at infinity. Hope you understood. Anyway, it's already 59 minutes, it's showing 58 minutes, okay? Let's stop the things here. Let's stop. In tomorrow's class, probably last class, let us study image formation by simple microscope for near distance, I mean a near point and at infinity. Second, image formation by compound microscope, okay, which once again we use in lab, biology lab. Third, image formation by telescope, and some knowledge about, let us study something about reflecting telescopes, where we have to study about acid grain telescope. Okay, before that, my intention is to tell you, please go through that video where we have studied formation of images when object is placed in front of convex lens. Just to particularly when the object is placed at F and object is placed between F and O. Let me repeat. When object is placed at F and object is placed between F and O. Okay? Thank you.